Hi everyone, in this video we're going to find the Taylor series for the function y equals sine of x. And I've started us off here with a few commands. The first one is the plot command. Notice that I'm in math mode to use the computational power of Maple. So we've plotted the original function here. I've also computed a few Taylor series approximation where my point of expansion is x equals 0, and you can see that changing the value at the end here changes the number of terms in my Taylor series, or in this case Maclaurin series approximation. Now I could create a plot with several of the series approximations. So for example, I am going to plot square brackets, several things. The first thing I'm going to plot is the original function, which is sine. The next thing I'm going to plot is just the Taylor series approximation with one term, which is x. I could improve my approximation by taking more terms in the Taylor series approximation. So I could plot the Taylor series approximation x minus 1/6 x cubed. Or I could even take more terms and go out to x to the fifth. Let's take a look at what we see. In the plot, I see the original curve, and that curve is there in red. At the point of expansion, which is 0, all of my approximations do a very good job. In fact, they do a perfect job of approximating the original function. But as I move away from the point of expansion, so if I move over here to pi over 2, you can see that the Taylor series approximations tend to diverge a little bit from my actual function, and the farther away I go, the worse they get. Some other things you can notice is that the fewer terms I take, the cruder my approximation. So if I take something like just x and I approximate sine with just the function y equals x, this straight line, it does a pretty good job when I'm close to 0, but then it gets pretty crappy as I move farther out. There is a wonderful tool here in Maple that I'd like to show you, and that is found under the Tools menu, and then we'll go to Tutors, Calculus, Single Variable, and we'll scroll down to Taylor Approximation. So here it came up with sine of x. You could type any other function you wanted in there. Let's do a degree 7, and we'll expand at the point x equals 0. You could choose different points of expansion.